Hey everybody, and welcome back to Kerbal Space Program RP-0. We're here in the VAB today because it is time to replace our aging Griffin launch system with something with a little more lift capacity. And to test said capacity, well, we're going to start off with this ridiculously inefficient it doesn't shut down guidance unit. But for test flights, we're probably not going to fly any actual payload. We're just going to be testing for weight and lift capacity. So we will be building out a launcher. Actually, show UI. Lead ballast is what we're looking for. There it is. Update. Hide the UI. What does that bring our total tonnage to? 7.72 tons. Let's up the utilization because that doesn't really matter. That takes us to 9 tons. Awesome. How about, okay, 71.45 tons. That's about what we need to do. We'll take that up a bit. 99.36 tons. If we could get this into orbit, that would be absolutely amazing. Actually, we can take that down because we're going to have the weight of the lift vehicle underneath it also to accommodate. So 86 tons is about what we're at. And now it's time to build something to carry it somewhere. So I'm going to speed this up and talk over it in post. I will see all of you in a bit. Alright, so this is sped up a whole lot. I'm going to try to keep up. But Saturn 1B control unit, and then form out the upper stage. Initially I decided to go with 4 J2s. That was excessive. Cut it down to 2. Trying to optimize for burn time, so size up the tank a bit. Get the... Looking to hopefully hit the full 8 minutes 20 seconds burn time on those. RCS system because we'll need it. RCS tanks. Additional boil off tanks because we're going to need those too. And then start to form out the lower stage, or really our launch stage. So we'll get the fairings built out. Upper half of the tank. Now, you should have guessed the styling cues I'm going to go here. The initial design called for one F1 engine at the center stack, and then now we'll build out the boosters, get their bottom tanks rounded, and then an additional F1 on each of the boosters, totaling 5. So our engine count remains the same, but I'm hoping that through optimization we can get much better lift. Alright, so I can't really zoom out enough to show you all of it, but expect changes to this upper stage as far as integrating this above the fairing, changing this fairing to one that accommodates a capsule on top instead of just a closed fairing, and widening out this so it doesn't look so positively stupid. But we're going to give this a shot. So I guess first we need to give it a name. Maverick 1. And this is the test vehicle. Save. And simulate 75 minutes. Actually, that would be great if I was doing a reentry test, but I am not. So we're just going to go for 25. That should be, yeah, 25. That should be well more than long enough to see if we can get this stupid thing into orbit. Here's hoping. Alright, thank goodness it's daytime. Oh wow, while zooming all the way out, you see exactly how ridiculous this whole thing actually looks. I don't know if I'm happy with this or not. Throttle set to full, SAS on, ignition. F1s take forever to spool. There they go. Initial thrust to weight ratio about 1.21. Should see us getting off the pad relatively easily. 1 second. Yeah. Sorry if that was a bit loud. These F1s are very, very loud engines, as they should be. Yeah, wow. This, I don't know how happy with this design that I am. I mean, obviously, you can tell where I'm pulling my inspiration for the bottom stage. And booster design, we're going to try a cross-fed fueling setup this time around and see if a single F1 engine can move this heavy thing through the atmosphere after getting a sizable bump in speed from these 4 F1 powered boosters. Although really, considering the weight at liftoff, they might need some help in the form of maybe some MIT-2s or even some additional side-mounted Keralox engines. It seems weird to have something that 5 F1 engines can't lift. But I'm hoping that with a more efficient displacement of their staging and going the 4-to-1 style like the R7 and Soyuz, that we could maybe increase this longevity of these engines, although they're still the most powerful engines ever made. Alright, coming up on booster SEP. And they're away. And some clustering there of the boosters. Not a very clean separation. We are actually losing speed. Yes, we are decelerating. This might be a problem. Alright, looks like our deceleration has stopped. We are now back to accelerating. Thank goodness, we're only moving at 700 meters per second. We'd really like to get that speed up, gain some altitude here, while also accelerating. Yeah, our relative trajectory is falling. We are closing very quickly on our apogee. If that doesn't start to climb soon, we are in trouble. Rut row. We've got another 6 minutes left on this engine. Barely half a G of acceleration currently. Time to apogee still falling. We are falling. Trying to adjust our angle in hopes of trying to recover some of this altitude, but not confident. Yeah, our rate of descent is increasing, not decreasing. Yeah, we're still falling. Alright, this is not going to work. Simulation terminated. We need to do some different things here. First thing I want to address is how stupid this looks. This is just a sped up thing of me adjusting the fairing to accommodate a capsule. No real point for a narration. Okay, now we can ignore all of this up here. I know it looks absolutely stupid, but we're going with it. Right, and now changes to the bottom as are necessary. I think one of the first things we're going to do is remove the fuel crossfeed. That did us no favors. We're also going to size up the boosters themselves. Now that we'll be lightening the core stage on our way up, we've got a little more room to work with there. Sizing down some tanks to deal with better weight optimization. And then finally getting some veneer thrusters on there to help us out with some roll control, and the addition of 4 Minutemen boosters to help us get off the pad. It'd be nice to have some separation motors on there too, just to make sure that they're not going to collide with anything, and get the alignment, and it's time to go again. Alright, so equally dumb looking because of that, but none of that's going to be the same on the real launch vehicle, I assure you. We won't be launching 80 tons of lead into low Earth orbit. Alright, ignition sequence start. Running. Clamps plus boosters. We're actually moving. That's a miracle. We are no longer cross-feeding the center stack, so we should be, yeah, draining lots of fuel from there, and hopefully that will aid with our falling down problem. Alright, we are coming up on SRB SEP. This is crucial. If it hits that center stack engine, we know this whole thing isn't going to work. If they fly forward and hit the center stack, this whole thing isn't going to work. They collided into each other. That's okay. I think. So far, we're still rolling and cooking. So. Doing much, much faster than we did last time on booster SEP. But we also made the boosters wider. G. Booster SEP. Still accelerating and climbing. Oh wow, I did not roll this over nearly fast enough. Our apogee is already up to 180 kilometer. I did not see that coming. We are not probably going to separate that fairing. For the sake of it, just looks really dumb. I mean, this looks really dumb, but yeah, what are we gonna do about it? And with these 4 venters, we have roll. Do we have? Yes, we do have roll control. This is literally the only reason they're there. The thrust they provide is pretty marginal at best, but it's nice to have roll control, and we'll probably need said roll control. And ignition on our twin J2s. We're seeing some pretty decent acceleration. We still are going to need to pitch up a bit. Our time to apogee is very swiftly approaching, and I'd really like to not fall back. We are not that high. 204 kilometers altitude. By the numbers, we should have enough to hit orbit, but with this these gravity losses and with this off-angle burn, we are not at peak efficiency as far as that is concerned. But best thing we can do is just see. I mean, if it gets close to orbit, I can assume that with a better flight path that maybe it could actually happen. But, you know, we'll see. Let's get a little RCS aid in here, because we are falling now. And climbing. What? Start taking this angle down a bit. 309 by 170, running on fumes. They have 67 meters per second left in the tanks. But we did it. We made it to orbit. And I think with a much better flight profile, we could possibly optimize that a bit. But that does remain to be seen. Now we'll go ahead and split those fairings. Oh, yeah, I forgot about all of that. Oh, not the button I meant to hit. That was the button I meant to hit. I wish I could write 86 tons on the side of this thing. That is very respectable, I have to say. But, so I'm going to go make some refinements, little tunes and changes here and there. Hopefully try to get it to look a little less stupid. If you've got any suggestions, please leave them for me in the comments below. I love getting feedback from you guys. It's pretty awesome. So, anyway, next time maybe we'll be doing some less simulated testing on this thing and actually try building one. Although I don't think it will be done by the time we have to start shipping things off to Venus. So, thanks for hanging out, everybody. I do appreciate it. And until next time, I will see you later. See ya. Alright, everybody. Sorry, just a very quick addendum to today's video. I was messing around with things and was having a lot of indecision about how to approach this particular situation. And this is the design I think I've finally settled on. We're going with the Maverick A17-2 is the series number for this rocket. This is just a dummy fairing. Our actual payload will obviously go in here. This is the upper stage. Still the same as from the very first version, just a couple of tweaks to its size. And its burn time is now settled on exactly 8 minutes 20 seconds, which is the maximum rated time for the twin J2s that power it. Below it, we have considerably sized up the core stage. The boosters are almost unchanged. I've added some Separatrons and a pretty paint job. And down at the bottom is where we get to the business end of things. The boosters are still individual F1s all on their own, and the core stage is up from 1 to 3 F1 engines all firing together. I included this little skirt because I thought it looked better, although that was not the texture I had on it. Although, and in all honesty, I tried to load this thing about 4 times and the game kept crashing. I'm hoping it's not a serious issue and that maybe it was a hiccup because I got it to load from the sub-assemblies menu without too much problem. So, we do also have cross-feed now on our fuel, since the 3 F1 engines at the core stage will provide more than enough thrust to feed this beast. The boosters will get it up to about 1,500 meters per second, and then the 3 core stage F1s will take it the rest of the way. Not quite to orbit, of course. It's going to need about 3,500 meters per second of the available 4,600 from the J2 upper stage to round out the orbit, and that's shooting for about a 250 to 300 kilometer orbit. So, this is our new ultra-heavy delivery vehicle, the Maverick A17-2. 7 because there are 7 stages that light on the ground, and the 2 for the 2 J2s that push the upper stage. So, I expect we'll get this into service pretty soon. We're going to need some heavy things to put into orbit to justify the cost. Just the launcher, without any reasonable payload, is 91,765 credits, making this, just the launcher itself, the most expensive thing this space agency has ever produced. Yeah, this thing is massive. It is a titan of a rocket, and hopefully it will see our crewed our crewed program extend beyond Earth and go interplanetary, because this thing can put 100 tons to orbit and not break a sweat doing it. So, alright, for real this time, thanks for hanging out, everybody. I do appreciate it. So, I don't know if you got any comments or suggestions or anything relating to the Maverick or anything else, really go ahead and leave them for me below. Again, I do enjoy hearing from all of you. So, thanks for hanging out, everybody. I will see you next time. Till then, see you later.